All right, so here is your angled forces with friction challenge problem. Kind of puts everything together, see if you can do everything at once. And I came across this little gem while looking up Calvin and Hobbes, and just so happened that Star Wars popped up when I typed in the word force. Shocking. So it says here, determine the coefficient of kinetic friction between Darth Vader, that would be this little cute dolly right here, and the ground. If Kylo Ren, that would be played by Calvin over here, is pulling on him with a force of 1.5 newtons at an angle of 40 degrees above the horizontal. So he's pulling him up and to the left. If Kylo Ren is also accelerating away from Ren here, so played by Susie, so cute, at 2 meters per second squared. So your job is again to determine the coefficient of kinetic friction. So give that a try, see what you can do, and as always, I'll be back in like 5 seconds to reveal your first, actually the answer, and then we'll go from there. So, on your mark, get set, do some physics. There's your answer, 0.277. At least that's what I got. I'm human, I might make mistakes, but that's what I got. I got 0.277 for a coefficient of kinetic friction, which makes sense because it is between 0 and 1. And if you need some guidance on that, I will be revealing your first hint in a second. So that's the force diagram. So you're going to make sure you got that force diagram correct. So let's see if you got that force diagram correct. So move. Come on, force diagram. You can do this. There we go. All right, so that's to be what your force diagram is. Okay, so make sure you've got your force diagram all done and done. You've got this angled force, which we broke into its X and Y components. We still have the normal force pushing up on the cute little dolly over here. And then we've got gravity down, friction's off to the side. So this is your force diagram. So give that a shot. Maybe you had something wrong. Don't forget your acceleration over here, and it's negative because we're accelerating to the left. So keep that in mind. So if that unblocks everything, then maybe give it another shot. If not, I'll be revealing your second clue in about 3 seconds. 3, 2, 1, and clue number 2. Do the net force equation in the y plane first. Technically, you could start with the x. That's totally fine. But you will get stuck in the x, and you'll have to go to the y. So you do eventually have to go to the y plane to find that normal force, because that does come in with the force of gravity. And when you do this, you get a normal force of 1.9. It was like 756, so I just rounded it to 1.98. So that's what you should get for that normal force. And if that's where you got stuck, then maybe that'll help dislodge you so you can finally get to that final answer. But if not, I'll reveal the entire thing in 3, 2, 1, and there you go. That's the final answer, final solution. Sum the forces in the x plane equals ma. This time you do have acceleration, and big thing here, we are replacing the force of friction with mu Fn through substitution. We are bringing the 1.98 we solved from the y plane into the equation now for that normal force, because that's the normal force that's responsible for friction. And when you do all that, you should get the 0.277. Hopefully you've figured out what you did wrong, or maybe you got right on the first try. So either way, congratulations for sticking with it, and I will see you in class. As always, if you got questions, ask them. Bye for now.